Afternoon, everyone. Welcome to the May 2023 edition of Innovation Insights. We've got three great presentations lined up for you today. Thanks for attending, and I'll just walk through a couple of slides to start with. One is just reminding folks about the value offering to IACMI members. You know, this is even more important now that the Department of Energy has renewed IACMI, which most of you should have already noticed by now. But again, around the themes of convene, connect, and catalyze, and then with a number of adjacent opportunities to engage IACMI, engage other members, and grow your business. Just a quick reminder, and you'll hear more about this from Mark Morrison, so I've only got one slide on it, it's almost time, it's next month, the IACMI members meeting in Knoxville, Tennessee. So if you haven't registered yet, please do, and Mark will give us more details on that. All of their previous innovation insights are recorded, and they are available on the IACMI website. If you just go to iacmi.org, click on events, innovation insights, you'll find every one of them there, including this one. So if you missed something today or you want to share with a colleague, please let them know that they can find that on our website. So that being said, I'm going to get us kicked off. Our first speaker is Amolak Badesha. Amolak is the CEO and co-founder of Orbital Corporation, Orbital Composites, and I will turn it over to him.
Oh, thank you, Dale. I think you need to stop sharing so I can show my presentation.
I'm trying to do that, so we're struggling with that. There we go. Should be good.
No, okay, yes, there we go.
Good.
All right. Let me know if that's coming through.
Looks great.
Okay, great. Well, it's great to be here. Thank you, Dale, for the invite, and we're a proud IACMI member and appreciate all the support we get through the various activities. So my name is Amolak Badesha from Orbital Composites, and today I'll be talking about the robotic additive manufacturing platform for continuous fiber composites. So Orbital Composites were a Silicon Valley startup and really looking at reinventing composites manufacturing all the way from meso to mega scale. And we are considered one of the pioneers in this emerging space of continuous fiber additive manufacturing. And by using these new techniques, we're enabling next generation composites aircraft. Just at the very high level, our goal is to obsessively drive down the cost of composites so that we can use it more ubiquitously in a variety of applications. And in terms of our business model, there are three categories. First, we're developing the robotic systems that enable these new capabilities. And we already are shipping these machines with a number of commercial and government customers. Second, we provide manufacturing as a service to our customers. And the focus here is to really apply this new breakthrough technology for these highly advanced applications. And finally, long-term, we're looking at developing a number of products from Orbital, taking advantage of these manufacturing processes. Some of the applications where we're starting to see a lot of interest and pull from customers in those three categories. I'll briefly touch on unmanned systems, hypersonics, and space applications. So I think it's best to look at one of the examples, use cases that we are working with the Air Force on, this idea of, can we 3D print high performance unmanned aircraft and do it at a forward operating basis. So in order to do that, we need to develop a variety of different systems so you can support different types of aircraft. So we have a number of platforms that we're developing all the way from a simple single robot platform on the left to Orbital S, which is a multi-robot system, but could also go inside a 10-foot shipping container, or Orbital F, which is a much larger 40-foot shipping container system. And the idea is that all these platforms are mobile, they can be easily moved around, and you have the ability to print very advanced composite structures with continuous fiber. And far to the right, there's another system called AMCM, which allows us to combine the benefits of additive and compression molding. And there was a webinar on this by Dr. Vladimir Kunk from Oak Ridge recently. So I won't cover that in detail. You can refer to that for more information on that. So this is just a snapshot Orbital E, Orbital S. Now, one of the unique things here is that we support a variety of end effectors, so we can print with neat thermosets, neat thermoplastics, continuous fiber, and even ceramics, and ultimately the same platform could also be used for metal or metal matrix composites. So it's a very flexible multi-robot platform that allows us to kind of push the boundaries of what is possible with additive. On the larger scale, we're collaborating with Oak Ridge National Labs and University of Maine to scale the system up to be able to print very large structures, in this case, 10-meter plus structures. And we have an example project where we'll be demonstrating printing a subscale wind turbine blade. The additive manufacturing and compression molding system. So now let me come back to this question of manufacturing these very high performance unmanned aircraft. So from direct to fly, print to fly, there's many structures like wings and fuselage, integrated wiring or lightning strike protection. All of those things we can print directly, and you can actually fly. There are certain structures where they are safety critical, and things like rotor head mechanics, control surfaces, propellers, those things where you also could have a lot of complexity in the structures. The AMCM process is very useful. So when we take all of these different capabilities and combine that, and then apply that to a product, that's where Orbital developed this very high performance unmanned aircraft that can fly in the tune of 200 miles per hour with very high end cruise efficiency. But the key thing is, again, is that we can print these one a day with our simple Orbital S robotic system. And not only print, but print, assemble, and fly in less than 24 hours. And that is quite a big breakthrough in this area of high performance aircraft. And we've demonstrated that actually with our test flights, that this is in fact possible. Now, extending that to higher performance, even more extreme applications, recently we've demonstrated printing carbon-carbon preforms at a dramatically lower cost and cycle time, as well as significantly higher performance. So coming back to the applications where we see a lot of interest is unmanned hypersonics, and our goal is to also launch the same printing system in orbit as well. So we have a number of projects ongoing now with the Space Force to get our printing systems ready for launch as well. Now, I talked through a 2-meter scale unmanned system example, but as you can see, our manufacturing platforms go to much larger scales. And so we've also been working on much larger aircraft systems, and cannot share what we have printed, but we have this quote from the Boeing team, the Phantom Works team, remarking this at the recent presentation we did at SAMPI, that we have printed one of the largest, most complex continuous fiber composites parts ever printed. And what we were able to demonstrate through this project is our ability to rapidly iterate, things that may take months and perhaps years, and bring that cycle time down to, weeks, while also simultaneously driving the cost lower to develop this next generation aircraft, while also simultaneously pushing the performance higher. And when you can combine those three things together, then it starts to become quite attractive and demonstrates what is possible. So just in summary again, we're a Silicon Valley startup based in close to San Jose Airport. We just moved into our brand new facilities, and we have a large number of equipment, robots, compression molding presses, and we're ready to grow and collaborate with customers interested in developing next generation breakthrough composites applications. And I think that is my last slide. I will pause here and see if there's any questions.
So I remind everybody, stick something in the chat or the Q&A, and I'll while people are doing that, I'll ask questions. What's the thermal range of thermoplastics that you can work with?
Yeah, so we've designed our systems to print with the entire range of thermoplastics, all the way from basic nylon PLAs to PEEK. So the entire range of materials is supported. Okay.
So on the continuous materials, are those printed using topregs, or are they printed using dry fiber and then you impregnate them in situ?
Yeah, so we have a special feedstock where we take dry fiber and do in situ impregnation. And that allows us to keep the cost very low. Okay,
so that's done on the machine, the impregnation?
That's correct.
Okay, all right. Let me see if folks have any other questions out there. Any feel for what level of investment somebody has to make for one of your machines? Let's just say the second size up.
Yeah, so the Orbital S, which is the second size up, I think.
Yeah.
So that's it's a configurable system. So you can choose between a single robot or multi-robots. So the price range could vary from anywhere between, let's say, 300 to 400K to 1 million plus, depending on the configuration.
Okay.
But we support a variety of end effectors, thermosets, thermoplastics, continuous fiber, and even machining end effectors. So the system is very configurable.
Okay. All right. So a couple of questions really focused on, are you only doing carbon fiber? You're also looking at glass. And then second, what resins in particular you are looking at for carbon fiber? And I think that's probably maybe from a thermoset perspective.
Yeah, so in terms of fibers, yeah, we can print with both glass and carbon. And resins, again, our primary focus is thermoplastics. And there we have a pretty large range, I would say about more than half a dozen resins, from basic nylons to up to PEEK, and more are possible. It's quite easy for us to incorporate new resins into our feedstock. But in terms of carbon and glass, we're focused on S2 glass as the high-end glass fiber at the moment, as well as standard T700 type of carbon fiber.
Okay, so the typical question that always gets asked, and it's here is, when somebody talks about additive manufacturing, so what sort of laydown rate have you got, or printing rate, pounds per hour, kilograms per hour?
So The laydown rate can again vary quite a bit. As you can see, we have the Orbital S is more focused on finesse of, as the picture you see on the screen, that's a much more fine-tuned, lot of curvature, a lot of intricacy going on in the geometry. So there, intentionally, you go a bit slower. But on the other extreme, we have a wind turbine blade application, like I talked about, the Orbital F application. That's a different type of deposition system that will be printing at very high speeds. Let's call it BAM type speeds. BAM is traditional BAM is printing with very high pounds per hour numbers. Let's say 100 plus. So our continued fiber system for that will be very high deposition speeds, whereas the Orbital S is more focused on more complexity rather than speed. But there's also other ways to gain speed. This is why we're big on multi-robot parallel robotics. So we can also gain speed by going parallel. Just like we have CPUs and GPUs. GPUs are good at doing a lot of parallel processing. So we believe the future is really multi-robot printing, where you can start doing a lot of parallel printing and gain significant speed that way.
Okay.
While maintaining the complexity.
So quick question with respect to the part you're showing, which you said was carbon. Obviously the part of the carbon comes after oven treatment, obviously thermal treatment. But what resin was used there? Because oftentimes people had used phenolics to get to carbon, but they're obviously thermoplastics with very high carbon assay.
Yeah, so I want to acknowledge we collaborate closely here with Oak Ridge National Labs, and in this case, this is thermoplastic resin Peak family, and we were actually able to get very high char yield on this application. Okay, great, thanks. All right, looks like we've got through the questions. Hold on, okay, one more. How does equipment respond to power outages in the field? Which can you restart the print from where you stopped? That is a great question. And in fact, we can very easily stop and restart jobs. So wherever you left off, whether you have an outage or you stop the print on purpose and then you want to restart that the next day. Our process enables that. We've done that. We actually do it all the time. You just flip the switch, go home for the night, come back the next day and start. Yes. Okay. Yeah. So you've simulated it, certainly. Okay. Well, appreciate that, Amolak, and look forward to seeing you at the members meeting next month. So. Sounds great. Looking forward to that. Thank you. Okay. So I'll let you stop sharing and we'll move on to our next speaker. And our second speaker today is Dan Allman. Dan's the Director of Composites Business Development for Globe Machine Manufacturing Company out of Tacoma, Washington. And you may know of Globe through various machinery things in the composites industry, but I'll let, like Rapid Clave, but I'll let Dan take that over. So Dan, you're up.
Dale, thank you. I appreciate the opportunity to speak to your group here. And Kim, thank you for coordinating everything. We'll get started. Can everybody see my screen?
Not yet.
Yeah. What's going on? This one.
Okay. You still need to put it in slideshow mode.
There we go. You see it now?
Yep, we're in good shape. Thanks.
Perfect.
All right. All right, we're going to get started talking about Rapid Clave technology and the Tarmax initiative. We're going to cover today, give you the quick rundown on who Globe Machine is. We're going to touch base on what is a Rapid Clave, talk about how it all began, talk about Rapid Clave manufacturing advantage and capabilities, and we'll jump into the Tarmax initiative and see how that is all relative to the next generation of rapid clave technology, and touch base on a critical element of the Gen 3 rapid clave and the Tarmax initiative, and that is our the tooling development that we are doing to enable some of the thermal efficiencies that we're realizing in rapid clave. Globe's a long-term machine tool company based out of Tacoma, Washington. They've been in business since 1917, one of the oldest machine tool companies out there that is still in existence, privately held, privately run by the Bamford family. They design and fabricate a variety of different automated manufacturing systems, primarily servicing the wood products industry and paper and pulp industry. A lot of these systems are lights out manufacturing systems for plywood, OSB, and MDF materials, for example. They started into composites in 2009 with the very first gen of rapid clave technology. We'll touch base on that in a minute. That technology was introduced in 2013 to the automotive market, and coming up in future state will be our Gen 3 rapid clave with low-cost tooling technology and also some thermoplastic technology that I'm not going to speak to today, but if anybody has any questions on that, they can follow up. What is rapid clave? Essentially, it's getting out of thermally inefficient traditional autoclave into a system that enables a higher fidelity of thermal control of that system. The system is designed for rapid manufacturing. You can get rapid clave with a fully automated tool transport in and out of the curing environment. It offers automatic connection of all process utilities. So all the utilities related to tool heating, process monitoring hardware, vacuum, those are all automatically connected when the tool is transported into the curing environment. The enabling factor within rapid clave technology is a rapid response of all the process utilities, rapid response of pressure, vacuum, and then rapid and accurate response closed loop control of directly heated tooling technology. Those are the key enablers to rapid clave technology and how it evolved and became commercialized in the automotive industry. That whole initiative started back in 2008 timeframe. If anybody here is a car person, I'm sure you remember the C6, Z06, and ZR1. The ZR1 had a rather unique hood with the clear view panel, so you could view the supercharger. And that hood was one of the first carbon epoxy applications for in automotive. And with GM, they've made some previously for some very niche market applications, but this was the first time for the Corvette that a carbon fiber epoxy hood was launched. It was produced in a traditional autoclave setup. Cycle times range from anywhere from 8 to 12 hours, depending on the specific part that they were making for those applications, excuse me. And GM was interested in taking that process across the entire product line for the C7 Corvette. So the base model and all the up performance process or platform variants, they wanted to produce all the body panels with the exception of front and rear fascias on using these carbon fiber epoxy systems. However, the traditional autoclave was viewed as too slow and too expensive to support that business case. And so GM challenged the supplier to go out and evolve that process to a higher level of production efficiency in order to justify that business decision to take carbon fiber epoxy materials across all the body panels for the C7. That's how the discussions with Globe started, and evolved. Coming out of that came the first rapid clave, which was developed. Come on, being finicky. Okay, here we go. All right. So that first system that was developed and launched in the machine on the C7 Corvette, the advantages were realized for a higher fidelity, rapid responsiveness of the entire thermal environment. That was achieved through directly heating the process tooling. Automated processes enabled rapid tool turns. The automatic connection for process utilities kept the operators out of the curing environment. Didn't have to climb inside the clave to connect all the vacuum tubes and everything else. The system is highly adaptable to support low or high volume production applications. The system has demonstrated continuously equivalent material properties to autoclave processes. It offers a significant energy savings over autoclave processes. The initial rapid clave that was processing the legacy materials that GM was using, we were able to get the cycle time down into the 60 to 75 minutes from the 8 to 12 hour. And then over time, working with the material suppliers, they tweaked those materials, and in production, depending on the application for the C7, they were running button-to-button cycle times of 17 to 23 minutes. That launched with 7 machines that met 7 rapid clave systems that met the up to 40,000 vehicle build set demands annually. And on that, we were fabricating the hood, trunk, roof, buttress, and various support beams of the C7 Corvette. What is TARMAX? TARMAX stands for Technology for Agile Rapid Manufacturing of Aerospace Composite Structures. I knew when we got that acronym from the Air Force that we had their attention. They gave us a 7-letter acronym. We were pretty impressed with that. Come on. So in partnership with the Air Force Research Labs at Wright-Patt Air Force Base and the University of Dayton Research Institute. So TARMAX is an initiative that is driving a system-level manufacturing engineering project to define, develop, and demonstrate the next generation of composites curing processes that supports the future state demands of higher volume, lower cost composites-intensive flight vehicles and defense systems. This is not only targeting the future state defense needs, but it's also of high interest to the future UAV platforms that everybody's fully aware of. I'm sure that's on this call. How are we doing this? How are we really approaching this? One of the keys to success for TARMAX is we've established the advisory board. The advisory board consists of, the who's who of the commercial aerospace industry. The leading composites technology experts are sitting on an advisory board that's providing guidance through the steering committee to the TARMAX initiative for what they think, what their view is that future state needs to be. We've established a materials characterization test matrix. UDRI is leading that portion of the project, where we are identifying materials, not only legacy materials, but the next generation fast cure materials. We're putting those through multiple iterations of characterization, proving rapid clave to autoclave equivalency, and then also rolling those into demonstrator applications for specific customers. We have a relevant common part demonstrator that is a bulkhead for a flight vehicle, a generic bulkhead that we use as a demonstrator for some customers. We were working with the next generation of fast cure materials and processing those on those relevant aerospace parts for demonstrators. Leveraging program partnerships to drive material and process certification efforts to get allowables and IR certification of materials processed specifically in a rapid clave environment. And part of this also is we have a globe-driven initiative that's evaluating multiple low-cost tooling technology options. We're producing those tooling technology, those specific tools for processing in the rapid clave. We're conducting thermal studies on the behavior of the tools, the behavior of that tool, the thermal efficiency of that tool in a rapid clave environment. And then ultimately will be demonstrated in our Gen 2 and our Gen 3 rapid claves. This opportunity has given Globe the chance to reimagine the entire rapid clave machine structure and machine design to improve manufacturing efficiency, improve thermal efficiency within the system, and reduce the CapEx requirements for purchasing this at a system level. Since it offered a clean sheet approach to the machine design and tooling and thermal management, we set up a design guideline for the engineering community to reference. First was safety. Second was high level of thermal efficiency and responsiveness. We wanted to accommodate rapid tool changeout. We wanted it to be flexible and adaptable for tooling and heating options for future manufacturing needs. There are multiple ways you can approach managing the thermal environment in the rapid clave. We wanted low cost, high thermally efficient tooling. We wanted the Gen 3 rapid clave to support ease of access for maintenance and service. We wanted to create a robust and highly interactive PC-based rapid clave process assistant for serve as an human and machine interface and machine learning as a machine learning platform. And we wanted to achieve the low cost operational and CapEx. And through all that, we wanted to leverage the knowledge and experience we had in rapid clave legacy in the Gen 1 systems to support the development of the Gen 3. Our first machine we're building for the Gen 3 is the part processing envelope. It's going to be 110 by 54 by 16 inches. So 110 inches by 54 by 16. We actually have a little bit more freedom on that Z-axis. We can go up to about 24 in that. But for right now, we have the space to do that up to 24. Oh, right now we're selling it as 16. This system is intended to be scalable to 192 by 72 by 42. We'll have a part process thermal limits of about 450 degrees and 550 with fluid supply. There's some tools to achieve the ultimate in thermal efficiency. We have a combination of thermal fluids heating the B side of the tool, as well as hot air from the A side of the tool in a highly controlled, balanced thermal process. Chamber pressure for our Gen 3 machine, we have 100 PSI design baseline that is scalable to 300. That scalability to 300 is an ongoing assessment. We haven't completed that yet, but that is our intention to take the new machine structure. This is a graphic of approximately what it's going to look like. But you'll see with the hinge design of essentially a cylinder, gives the operator a lot more access to the system. And so that aligns with what our customers are asking for. Get back to tooling. Tooling, we have several different options here for tooling. Each comes at a different cost, a higher cost. The higher the cost, the more the thermal efficiency you can achieve in the system. Tooling option number one is just a thin wall tool plate. You process this thin wall tool plate. It can be anywhere from 80 to 300 thou thick, depending on the size of the tool plate. You would drop that tool plate onto a preheated hot platen surface inside that system. The tool plates are very, very short-term lead times to produce. They can be produced with either traditional CNC or some of the new and very innovative 2D to 3D robotic forming processes that can take a sheet stock of virtually any type of metal material and form that from 2D into 3D shapes. We've been evaluating that technology extensively. It can support limited production volumes. It is the lowest cost tooling option for the system. The next option would be taking that same tool plate and adding fluid tubes to the back of it. There are multiple ways you can approach this. We feel we have a way that is highly thermally responsive, yet comes with a low cost. These tools can be produced again by CNC or the robotic tooling processes. This tooling will install directly on a rapid clave exclusively designed tool base with an exclusively designed process utility connector. Tool lead times for this can be as short of 4 to 6 weeks from CAD. And then ultimately getting into more like automotive type volumes where you have a heavy wall tool plate, dedicated tool structure, nominal wall tool thickness up to 500 thou. These are primarily for high volume applications like some of our customers are interested in the transportation industry and the automotive industry. It delivers cycle times pretty much equivalent to what you can do with tooling option number 2, but this brings durability in the tooling. This is tooling that would last for automotive type product cycles of 7, 8, 10-year automotive cycles. Tooling cost versus cycle efficiency is kind of spoke to here in this chart. Obviously, the lower the tooling cost, you pay a little bit of a penalty in cycle efficiency. We can still deliver sub 45-minute cycle times in the Gen 3 rapid clave due to its thermal efficiency using just the low-cost tool plate. But as your production volumes start to ramp up, using the eVTOL industry as an example, you can take that same tool plate, you can modify it, and increase the thermal efficiency to improve your productivity, get you down into the 20-minute cycle efficiency, 15-minute cycle efficiency, and then ultimately, if you want the ultimate cycle efficiency with the high-cost tooling, you can get down into the 5-6 minute button-to-button cycle times. So the enabling technology within rapid clave is primarily driven by how we manage the thermal environment and the tooling technology. That's it for my slide deck. I'll open it up for any questions.
Thanks, Dan. So we do have a question came in. Is the focus legacy resins, for example, epoxy, typically used by aerospace, or is Tarmac considering alternative thermosets or thermoplastics?
Tarmac is looking at primarily thermosets. We are working with epoxies as well as some unique new material technologies. We've looked at some monomer-free materials, but yes, we are open to look at a variety of different thermoset material technologies. We haven't ventured into the thermoplastic arena yet, other than some of the the liquid thermoplastic processes.
Mm-hmm.
We've looked at some of those, but primarily we're focusing on thermosets.
Yeah, it would seem you're right now a bit temperature limited, if I recall, 450, which would be for DF, which would get you up to BMI processing.
Right.
Yeah.
Right. Yeah. The matter of fact, that thermal limit was a 450 was requested by a customer specifically interested in processing BMIs.
Sure. Okay. What's the typical tool change time? How fast is the utility hookup and heat up time?
For a okay, it depends on the level of automation that you want to deploy for transferring the tool in and out of the system. You can make that process fully automated. You can where you could achieve a tool changeover in and out of the system within a minute, 2 minutes, or you can have in the case of the system that's going to be installed at UDRI, that's going to have a lift assist pick and place gantry that will swap out the tool plates in probably 5 to 6 minutes.
Okay.
Everything's staged properly. So it depends on the level of automation that you want to achieve, and then connection of all process utilities doing that is automatic. Everything's connected through a globe exclusive utility connector, we call it. And thermal efficiency, the ultimate thermal efficiency that we achieved in the Gen 1 rapid clave using only fluid heated tooling, we were able to ramp up at about 120 degrees a minute. Mm-hmm. In that system. That's demonstrated. That's commercial technology. Using the Gen 3 system with the combination of fluidized tooling and a very efficient hot air generator system that we're deploying in the system, we fully expect will be, I'm going to say 150 to 160, 170 degrees a minute ramp up rate.
All right, and we got one last question, and that is, what other markets other than high rate aerospace you think you can apply this technology?
Well, the ultimate, well, not the ultimate. One of the areas that we're focused on, Dale, as you're well aware, I spent 24 years in the automotive arena. We have generated interest in the automotive market with this, but right now this system and the program is focused on the commercial aerospace market, the commercial and defense related aerospace market. But any application that could benefit from rapid process cycle efficiency using rapid clave technology is something we're interested in talking about. If anybody has any ideas or any application interests, please reach out to us. We have We have opportunities to do application development and process demonstration work in Dayton today.
Okay, good. So there are 2 questions that are in the chat. I'd appreciate you going in and answering those in the chat.
Sure.
Okay, and then we'll move, so we can move on and get our last speaker in before the hour is up. So stop sharing your screen and we'll bring up Mark Morrison.
Thank you, Dale.
Thanks. Yeah, just go in and type answers to those in the chat. So, okay, so our final speaker for today is Mark Morrison. Mark is the Director of Communications for IACMI, and he's going to give us a sneak preview into our summer members meeting, which is coming up in 4 weeks. So, Mark, the floor is yours.
Hey, thanks, Dale, and hope everybody can see what's on the screen.
Yes, we can.
And hopefully some of this will go away. So as Dale mentioned, and hopefully all of you are aware that it's not a surprise that the IACMI Summer 2023 members meeting is coming up in June. So June 20th through 22nd to be exact. And we're going to convene in Knoxville. And so let me just kind of show you a little bit about what's going to be talked about. Let's see. So right there we go. So those of you that are familiar with Knoxville, Knoxville is called many things, including the Maker City. So our members meeting it's very interesting and relevant that we'll be in Knoxville, being that we are involved in manufacturing and with you and our members. So Tennessee has become a key epicenter for advanced composites and manufacturing innovation. It's an important state for IACMI and our members, including core partners, Oak Ridge National Lab, University of Tennessee, and Vanderbilt University in Nashville. Tennessee is home to 4 key facilities within the IACMI network. The Fiber and Composites Manufacturing Facility at UT, Oak Ridge has MDF and CFTF, and then the Laboratory for Systems and Integrity and Reliability at Vanderbilt. So it's obviously we're headquartered there, so we're looking forward to hosting our members in Knoxville. One of the key things, it's very clear to us, we use it as our tagline logo, many of you will call it, but literally the purpose of what we're doing is bringing our members together so that we can convene. And then while we're convening, there's the opportunity to connect, literally to connect in large meetings, small meetings, networking. It allows our small, medium enterprises to interact with larger companies and vice versa. And then literally out of this, we see projects and solutions that are catalyzed from this connecting and convening. High level, what's the agenda? So if you go to the website, iacmi.org, you can see the agenda, but I wanted to kind of show you just the high level. On Tuesday, the first day of the event, we're going to kick off with the IACMI working groups. You can kind of see them here. We've got 4 working groups that start at 8 in the morning and they wrap up by 4:30. And then we have a unique tour for those of you who have not had a chance to tour the Department of Energy's manufacturing demonstration facility at Oak Ridge. We have our tour that's going to start at 5 o'clock and go for an hour. Buses will be at the hotel, leave at 4:30 to take the folks who are touring MDF. I do want to point out that is limited to the first 100 that sign up. So I think we're about 70 at this point. So those that are interested, I encourage you to go to the website today if you haven't already registered for that tour. On Wednesday, it's a full day of speakers, presentations, and networking. Registration breakfast starts 7 to 8. And then we have our presentation program gets underway at 9 a.m. and goes till 5:30 in the afternoon. That evening, those of you that are familiar with IACMI members meeting, you know that a key portion, one of the things that we really pride ourselves and people look forward to is a networking reception. This one's going to be at the Women's Basketball Hall of Fame, which it is the only Women's Basketball Hall of Fame in the country. And we're looking forward to having a reception there with hors d'oeuvres and beverages. And then Thursday, we're going to pick back up with the Future Mobilities Vehicles Working Group, 7:30 to 9:30. Then we'll have a half-day program with presentations. Networking again starts at 9:45 and will be wrapped up by 12:15 or 12:30. So that's a high level view. The hotel is the Marriott Knoxville downtown. The deadline to register and get the discounted rate has been extended to May 31st. We had previously communicated that the deadline was today, May 22nd, but Kim Hooden has been able to work to get that moved to May 31st. So I encourage you to book your hotel rooms today if you have not already. Really neat location. It's been totally, it's literally new since the beginning of the year. It's a really neat location downtown next to the Sun Spear and the World's Fair Park, and just a short walk to restaurants and places of interest nearby. As I mentioned, I have the networking reception at the Women's Basketball Hall of Fame. We'll have buses that run a loop that will take people to the reception Wednesday after the program. A really, really unique opportunity. It's whether you're a basketball fan or not, there's a lot of history that's involved in this building. And it's really, I think you're going to be very impressed. Number one, you're going to be able to interact and network with members, but you can even on the bottom floor try your hand at shooting baskets and some dribbling exercises. We do have an impressive lineup of speakers, presenters, and panels. Some of those we're waiting on some confirmation, and we'll continue to share those as we, let's see, am I still sharing? I hope so. Yeah. And we'll share those as they become available. What I do want to point out is that we're very pleased to have Wenjian Dai, Dr. Dai from the Department of Energy from AMTO, and she's going to talk about the role composites play in advancing DOE's clean energy goals. As Dale mentioned, April the 11th, DOE announced funding renewal for IACMI, and it was very clear from Steve McKnight, who was in Knoxville to make that announcement, as well as Secretary Granholm, that composites are playing a huge role in helping DOE achieve their goals. John Korsgaard, many of you know him from LM Wind Power. John's going to be talking about challenges in manufacturing large wind blades. So I think that's going to be a key speaker. John's going to speak on Thursday. So again, we'll get that agenda updated on the website. Marcy Offner from Composites One is going to lead a diversity, equity, and inclusion and assistance workforce panel. Very pleased with the panelists that we brought in and talking about discovering hidden talent. This is a topic that our members have said that we need to talk more about. And so that's why it's back on the program this year. And then we're very pleased to have a speaker from ACMA. The actual person will be confirmed this week. But to talk about ACMA's Climate Impact Project. So I think we all see what steel and concrete are putting out there when it comes to their goals with ESG, and what we need to be talking about and be ready for. And I know Joe Fox and others are on very well versed on this too, but is how are we going to be ready for composites, and how are we going to respond to our members, but also to our customers? So again, a very strong panel. In addition to the ones I just mentioned, we've got working group report outs. So in addition to the working groups, during the main session on Wednesday, we're going to have our working group leaders kind of give a report out on what's going on. And then we have other programs, as you can see on the screen. I'm not going to go through this. This is the high level or the day for Wednesday, our main session day. So you'll be able to get this agenda very soon. But bottom line, you kind of get a sense, as we said, we're going to open up welcoming remarks, and you can kind of see the agenda here. Hopefully, many of you already know the benefits of attending a summer's members meeting. I'm not going to go through all these over to the right, but we are very pleased that we can bring our U.S. Composites community together. We're now over 130 active member companies strong, and we're looking forward to the momentum that we've got going into the year and going into the second half of the year. So again, we're looking very forward to hosting everybody. Registration's underway. Hopefully, if you follow our information, you've seen it, but you can go to iacmi.org You'll find all the information, and you see the URL that is allowed here. On the website, you'll see how to register. You'll see the hotel room information. And if you have any questions, I encourage you to email me or reach out to Kim Hooden. So Dale, that's a few slides that I wanted to share this morning.
Thanks, Mark. Great to cover all that. You mentioned the reception and said there'd be hors d'oeuvres and cocktails, but people aren't going to go home hungry from that. That's when we say hors d'oeuvres, we really mean a meal. So there's plenty to eat there. So nobody has to go out for dinner after.
Good catch.
Yeah. Okay. Yeah, I think it's gonna be a great meeting, great agenda. Still finalizing a couple of details, but should be a nice time of year to be in Knoxville. It's the longest day of the year on the 21st, and so the sun will be down really late. So lots of activities that people can do on the evenings before and still have lots of daylight. So.
Yeah, one thing I'll mention too, Dale, many of you saw in the pictures the Sun Spear. If you haven't been in it, you have an opportunity. We're actually going to be able to provide free tickets to members while we're there. So they'll be able to go up and get a larger view of Knoxville and the Smoky Mountain region.
Yep. Yeah, great views of the Smokies from up at the top there. Yeah. Okay. Well, we're gonna finish a little bit early today, but I don't think anybody's going to mind having a few minutes left on their schedule. Unless I don't see any questions out there at the moment about your presentation. I think Dan's taking care of the ones from his. So we will close today's Innovation Insights. Just remember, it will be available on the website probably within about a week. And we look forward to seeing many of you, or most of you, at the IACMI members meeting next month. So thanks all.
Thank you.
Thanks, everybody.